as you can as well. So we are up and recording. All right, so tonight we'll talk about P&ID, and we'll kind of zero in on some pneumatic circuits first. But what does P&ID mean to you guys?
Plumbing and instrumentation.
Yes. Piping or plumbing and instrumentation diagrams. That's exactly what we're talking about. So we've used AutoCAD Electrical at this point to do drawings of schematics. We've used AutoCAD Electrical to do drawings of panel layouts. And now we're actually going to be able to do some piping or some instrumentation diagrams with this as well. And I'm going to zero in on pneumatics tonight just to get some exposure to it. But we'll do some more of this next week as well. So we'll spend a couple weeks playing around with this. All right, so first off, if you don't know what we're talking about when we say piping and instrumentation drawings, this is what we're really talking about. If you look at this drawing, and I realize it's kind of small in the back there, but what you'll see on this without having to get too detailed is you'll see things like you might see air compressors and valves and electrical and hydraulic and pneumatic and all kinds of things, right? What we spend a lot of time on in this class is talking about the PLC I/O modules and the power distribution circuits and all of these different things, right? And then the panel layout. But what we know is that there's a lot more to a set of prints than just the electrical controls, right? The electrical controls actually control things. And that could be a solenoid valve. That could be a motor. It could be a damper. It could be lots of different things. So these drawings actually deal with some of these other components, the piping, the instrumentation, and the other pieces that go together with this. All right, so P&ID is a piping and instrumentation diagram. It's a detailed diagram in the process industry which shows the piping and process equipment together with the instrumentation and the control device. So that's what we're really looking at. When you look at these lines in here, you'll see some of the lines have dashes, some of the lines are straight. That could be a mechanical connection, that could be an electrical connection, that could be piping, that could be, in some cases, your components will be white in the middle, and that could be a pneumatic component, and they may be filled in. That could be a hydraulic component. So you'll see different symbols meaning different things. So tonight we'll start off with some pneumatic circuits. And first off, why do we use pneumatics? What are pneumatics? Everyone's sitting in front of a robot right now. What's on the end of that robot? Yeah, it's a pneumatic gripper, isn't it? Why do we use a pneumatic gripper on the end of that robot? It's cheap. That's exactly right. That cylinder that's actuating is fairly inexpensive. And the other thing is we have service air in this room. Just like you would in any facility or plant, you have service air all over the plant, and you can use that service air for a lot of different things, right? But one of the things you can do that with the service air is actually drive pneumatic components, pneumatic motors, pneumatic cylinders, all kinds of different components, just like we could with hydraulics. So some of the benefits to working with the pneumatic circuit, which really means air as a power source is what we're really talking about, is that air tends to be clean. Hydraulics isn't always very clean, meaning that hydraulics, you almost always have little drips and leaks and all kinds of things going on, but you can get some really big hydraulic components that can move a lot of stuff, right? Air is very clean, and it's very easy to route around. You'll notice on these robots, they're just little rubber hoses, right? And I can plug them in and plug them out. I don't have to have special O-rings and gaskets and all kinds of other stuff like I would if I was dealing with a hydraulic manifold, right? So it's a little bit easier to work with. It's low cost. So we have a compressor in this building. We have a dryer in this building. Way down in our boiler room, there's a compressor and a dryer, and that distributes air all over the building. I also say that there's a limitless source of energy. Why is there a limitless source of energy? Yeah, as long as the atmosphere has air in it, we can compress it and we can distribute that air, right? So it's not a limitless source, right? I mean, but essentially there's more air than we could ever use. So we can compress it and we can distribute it. Pressure is transmitted in all directions, so it's routed wherever these pipes take them. And when it goes into a cylinder, it's routed wherever the cylinder or the solenoid is going to route it. So we can route it in one direction and extend and route it in a different direction and retract. And it's very easy to automate using electric solenoids. This is a good quiz question for next week, and I realize everybody in here is in a different spot. If you're coming out of an electronics program, you maybe are very familiar with this stuff, and you're like, yeah, that's easy, that's a cakewalk. If you're coming out of or not an electronics program, probably not electronics. If you're coming out of an automation program, you probably have worked with this quite a bit, right? If you're coming out of an electronics program, you're like, I don't know what you're showing me right now. And if you're coming out of electrical construction, you might say, yeah, I've done some work with pneumatics, but not in great detail. If you look at a pneumatic control valve, like what I have right here, this first one, we're going to call a two-way, two-position valve, okay? The positions are really easy. The positions deal with the amount of blocks. That's really it. So I can have 3 blocks on a pneumatic control valve. I can have 2 blocks on a pneumatic control valve. You can even have 4 blocks on a pneumatic control valve. What that means is each one of these blocks is essentially a position in which that valve can be put, okay? The two-way, from our standpoint, we're going to think of it this way. We're really going to think about it as kind of the number of ports, okay? I can come in here, and I can come in here on that position. I still can come in here, and I can come in here on that position. That's all I can really do, all right? Then you get into a 3-way 2 position. There's still 2 blocks. There's a block on the left. There's a block on the right. But what do you notice about the number of ports? There's 3 ports. There's 3 different routes in which air can enter that position, right? So we call that a 3-way 2 position. If I go down a little further, this is one of our most common right here. This is a 4-way 2 position. So in this particular case, I still have 2 blocks, block 1, block 2, and then I have 4 ports. I can route in here, I can route in here, I can route in here, I can route in here. And then finally down on the bottom, you'll see it's still a 2 position, but now I have 5 ways. So you can see I've got 1, 2, 3, 4. Essentially I have 5 ports. So really a 5-port 2 position is what you're really looking at in that particular case. Now, the way we can control these valves varies dramatically as well. So this valve is going to route air. Instead of routing current now, we're going to route air in different directions. Now I can control that valve a number of different ways. I can have a spring mechanism that controls the position of that valve. I can have a manual handle that I can press that controls the position. I can have a push button, a lever, a mechanical, kind of almost like a limit switch. Something's going to press it, right? I can have a solenoid. A solenoid is one of our most common. That means it's going to be electrically operated. Something electrically is going to turn on that coil like a relay, but in a relay where the coil is a magnet and then the contacts are closed, in a solenoid, the coil is still like a magnet, but what it's doing is it's changing positions of the valve is what it's really doing. Then you can see air pilot's got to have air controlling air. That's possible. There's another version of an air pilot, and then there's a detent. This one down here is the most common one you're going to see, and it's the one we're going to use tonight, so you're definitely going to see it. How many ways and how many positions on this valve? 4-way, 2 positions. I count the number of ports. I look at the number of blocks, right? So I can see the 1, 2, 3, 4. That's my ways, and I can see that there's 2 of those square blocks. That's the number of positions. You'll notice in this particular case, it's a solenoid or an electrically operated valve. You'll see that on the left there, right? It's a solenoid or electrically operated valve. And then it's a spring return. So right now it's shown in its de-energized state. What that means is the coil is not energized right now. So the spring is pressing it into the position shown right now. When I energize the solenoid, what's going to happen? That's going to shift across. Exactly right. When I energize that solenoid, this block is going to shift in that direction. So right now, air would be coming in here, right? It would be going over to a cylinder or a solenoid. If I had like a little cylinder up here, this is going to be the worst drawing of all time, folks. I apologize. But imagine I've got a cylinder that's protruding out here. And what's happening right now is air is coming in here, and it's pressing that and then it's returning on here. Do you see that? How that would work? Air would come in here and it would press on that cylinder and it would push this piston out. Does that make sense? What's going to happen is when I change that, I'm going to change the direction of flow, aren't I? So I'm going to push this block across. Let me see if I can just delete this and get rid of that. Discard, and I'll go right back into my screen here. So now imagine I'm coming in here. It's the same exact thing. I just energized the solenoid. So now instead of air coming in here, now air is coming in here. And if I could draw that same piston that I just had, like this, where the piston was pushed out, now air is coming in here. Do you see that? And it's going out here. So now that piston's being pushed which direction? It's being pushed back inward, isn't it? So it's pushing that piston back into the system that you see right there. So that's exactly what we're looking at, and then the air is going to return. If you look at those little robots, on the front of them, you'll see a little solenoid valve where that blue tubing goes. And then coming out of that blue tubing, you'll see some shiny gold little mufflers is what we call them. Do you see the little gold mufflers on the side of the solenoid valve? What are those mufflers for? Yeah, they're exhaust. If you don't have those mufflers in place, when that solenoid is hitting, all you're going to hear is a constant steady air pressure. It's like someone's holding an air hose with 120 well, it won't be 120 psi. It's whatever it's regulated to back there. It could be 20 psi just spraying out constant, right? But those mufflers will actually muffle that noise, and they'll exhaust that into the atmosphere. And the atmosphere, again, becomes our tank from which we do all of this work, right? And so what these pneumatic cylinders are going to do is they're going to convert that compressed air into linear motion. And there's lots of different cylinders. The one thing I'll note on this diagram, though, that I think is kind of cool to look at is you'll note right here, you see that little arrow coming in? See how that little arrow looks like this? It's not filled in. If I was to fill in that arrow like this, what would that mean?
Oil.
Oil. Is exactly right. If I leave it empty like it is here, this means it's an air cylinder or a pneumatic cylinder. If I fill it in like this, this means it operates on oil. And in this case, oil means we are working with hydraulic fluid instead of working with air, right? So that's the big difference. That's an easy way to identify it on all of your fluid power symbols. If they're open like that, you're talking about an air system. And if they're filled in, you're talking about an oil system. All right, so here's where I want you guys to open up AutoCAD Electrical and follow along with what I'm going to do. And I'm going to shift away from this little bit of work we've been doing right now. I'm going to hit Escape. There we go. Discard my annotations. And I'm going to go into AutoCAD Electrical. And I want you guys to go ahead, and once you're in here, I'll give you a minute. I want you to open up a new drawing. So I'm going to go into my AENT 3120 folder and open up a new drawing. And I'm going to call this my P&ID demo. You guys can call it whatever you want, but that's what I'm going to work with. I'm going to make sure I get my template. Some of you guys may actually have a new template right now. Mary and I were talking before class about we need to create a nice new Dunwoody template based upon the things that you guys learned last week for the title block and scaling and things like that. But I'm going to work off my old Dunwoody template for right now. And I'm going to go ahead and hit OK and open up my drawing here. I'll set the project defaults, and I've got everything where I need it to be. All right. So now there's a little part that's a little bit different that we haven't used yet that I have to show you guys here. So in your menu up here, right underneath your icon menu, you'll see where it says Insert Components. If you click that little Insert Components down arrow there, I think a lot of people don't even know this exists, but under Schematic, and then this little Insert Components down arrow, that's right here. What you're going to see is three little icons underneath here. Insert pneumatic components, insert hydraulic components, and insert P&ID components. These are the ones we're going to spend a couple of weeks talking about. and that we're going to be working with here. All right, so the first thing I'm going to do is I'm just going to go into insert pneumatic components. And you could also bring up the command there, AE pneumatic, if you happen to remember all that. But when you go into insert pneumatic components, it's going to bring up all the different pneumatic components that we can use. And I'm just going to go ahead and go into the four-way valves. You'll see you have your three-way and your four-way valves. And under four-way valves, I'm going to have a, let's see, a two-position. And actually, the one that's the most common, they've actually already got kind of highlighted here. Single solenoid spring return. You'll see it kind of down on the bottom here. Single solenoid spring return. I'm going to grab that. I'm just going to throw it into my drawing. And I'm going to call this valve 1, just VAL1. And I'm going to hit OK. Now if I zoom in on that, this is where the scaling comes in from last week. It's interesting because what you're looking at right now is a little bit strange to consider. What does this symbol mean on A here? Spring. So that's going to be a spring return. What does this symbol mean right here? Solenoid. Exactly right. And how about this symbol here? Yeah, this is a manual operator of the solenoid. This is very, very common that when we have a solenoid actuated valve, we'll actually have a button that we can press to actuate it too. Why do you suppose they include a button? You could test it. You could manually override it. There's lots of things you could do with it, right? So it's kind of nice. So you got two different ways that you can actuate this guy. You can do a solenoid or you can do a manual. It's not necessarily a push button. It's a manual override. Okay. Now, before we do this, though, I do want to insert some other stuff. Oh, and by the way, how many ways on this valve? 4 ways. How did you know there's 4 ways? Just count the ports. All right. That's not always going to be true for you, but for most of what we're going to do, look at the number of ports. That's the number of ways. How many positions? 2 positions. There's only 2 blocks that can be pushed into the circuit, right? So it's 2 positions. We're going to start this circuit very similar to the way we've started any other circuit. And actually, you know what I'm going to do? I'm going to get rid of that guy for right now. I'm going to delete him. You guys should delete him too. And I'm going to make sure that F9 is on. What does F9 do? Snap. This one's kind of critical because the way these components line up to do the piping and to do the connections, they kind of need to line up right, and you really want snap to be on for this. So we're going to make sure F9, make sure your snap is on, which mine is. And then the next thing we're going to do is under schematic, I'm actually going to insert a ladder. And you might say, what the heck, you're inserting a ladder? Yep, I'm inserting a ladder. And under insert ladder, I'm going to pick a 3-phase ladder. And the 0.5 spacing I'm fine with. And I'm going to hit OK. So a 3-phase ladder is going to come in. And I'm going to start drawing that guy right here, right up at the top. Oh, you know what, though? I don't want to do that yet. I'm going to hit escape. The reason why is because I'm not using this ladder for the purpose of electrical connections. So I don't want to have these, I mean I could, but I don't want to have these individual lines coming off. So I'm actually going to hit escape, and I'm going to try that one more time. I'm going to go to insert ladder. I'm going to go to 3-phase. Can I turn those off? Thought I could. How about no rungs? No rungs isn't going to apply anyways, is it? Yeah, maybe it does. So when you're under 1-phase, click on the no rungs, and then switch to 3-phase. Let's see if that takes care of it for us. So no rungs, and then 3-phase. And now let's see if it draws it in there without. No, it still does. It's fine. It's going to, oh, it did. As soon as I clicked away from it, you see what it did? It got rid of them. This is all I'm looking for right now. I'm looking for 3 lines coming in. And I'm fine with the numbers. I think we'll leave the numbers whatever they're at. You guys could have selected those numbers, right? And made them whatever you wanted to. But we're going to do it a little bit different today. What we're going to do is we're going to put some reference arrows on these lines. What would a typical reference arrow be for our three phases?
Line 1, line 2, line 3.
Line 1, line 2, line 3. But we're going to change that right now. So under source arrow, I want you to go down to reference only arrow. And I want to go to the arrow tail up. So reference only arrow, arrow tail up. And I'll place that one right here. And this is why the snap being on is kind of handy too, right? It's going to line it up perfectly. And on this one, I want you to call this just PSI. So instead of calling it line 1, line 2, or line 3, I'm just going to call it PSI. And then I'm going to insert another one. So I need another reference arrow, tail up, and I'm going to call this, I'll call it EXB, or maybe EXHB. I like that better, EXHB. And then I'm going to insert one more reference arrow up. Would it be helpful if I turn that other light off? I'll do that. I can see that those blue letters are nearly impossible to see. Don't fall asleep on me. All right, so EXB, and then this one will be EXHA. Any guess what those are going to be? PSI, EXHA, and EXHB. What does that stand for in this particular drawing?
Pressure and exhaust.
Pressure and exhaust. That's really all we're looking for is pressure and exhaust. That's what we're going to call these three guys, okay? So then, now is where I want to actually put something in here, right? So let's say that I'm going to go ahead and insert some sort of control valve. So now we'll actually go grab our control valve. So now we'll go back into insert components. We'll go back to our pneumatic components. And we're going to go find that four-way valve again. Now, one thing to note right now, you could pick from your own left operators. Like I could pick my own three-way valve without operators on it, or four-way valve without operators on it, and then I could put whatever operator on it I want. So I could do that customized. But if you go into the four-way valves, the one we're going to use is the single solenoid spring return. And when you place it, it's going to place vertical like you see right here. And again, my snap mode is on, which is very important. When I come into here, it's going to get whatever rung number it's going in on, just like an electrical component would, right? So valve 36 is what this is going to get. Now, prior to placing this, though, I'm going to hit OK repeat. Why am I going to do that? Because if I want to place another one, I can just hit OK repeat. And I could place another one right below, couldn't I? So if I wanted to place another one right below and place it right here, I could. And now I have valve 36 and I have valve 39. I've got two of these in my process drawing here now, right? And they look pretty good. All right, so now what I'm going to do is I'm going to go ahead and wire those guys up. How do you suppose we wire those guys up? The exact same way we've wired everything up, right? So I go to my wire tool, and for my wire tool, I'm going to go, and this is why that snap mode is handy. See that? It goes right to the spot. And because these have those distinct lines, it's kind of important. So I'm going to go to my pressure right here, and then I'm going to go to my exhaust right there. So now you can see what I've got is I've got my pressure on the in, coming in on that in arrow, and I've got my exhaust coming out on the exhaust arrow. Now you might say, well, wait, EJ, we don't have any mufflers. We should probably have a muffler in here somewhere, right? So we're going to go ahead and we're going to install a muffler too. Now I'm going to treat this maybe more like it's, I don't know, maybe it's more like a solenoid bank system, and maybe there's lines that feed all of them or something. Yeah, they're stacked up. So what I'm going to do is I'm going to do this a little bit funky, and this will look strange to you guys, but what I'm going to do is I'm going to go down to the bottom, way down to the bottom of my rungs, and the first two are exhaust A and exhaust B, right? So what I'm going to do is on exhaust A, right here, I'm going to go back into my components. I'm going to find my pneumatic components, and I got to go find a muffler. And you can see that in that list of pneumatic components, there are definitely mufflers in there. And I just want a plain Jane muffler. They've got strainer mufflers, they've got separator mufflers, they've got variable mufflers, they got all kinds of mufflers. I just want a plain Jane muffler. I'm going to click on that, and then I'm going to place it right on the bottom here. Okay? And then I'm going to hit OK repeat. I'm going to place another one right there. And then I'm going to hit OK. So now I have two mufflers on the bottom of my exhaust. Does that make sense, guys? And then I might actually move these tags. So I'll click on this tag and just kind of slide it underneath because I don't like how they're sitting on top of each other. So I'll click on this tag and slide him underneath too. So I got muffler 50 and I've got muffler 50A as my two mufflers that are in the system here. So when I exhaust out, it's going to come back into this line and it's going to exhaust out. Now these mufflers could have been right on the solenoid valve. They don't have to sit on my lines in, but I chose to put them there. The only reason why is because that's how it looked on the submarine prints. So I go off of that same idea. It's kind of a strange deal. A lot of times you'll see those mufflers will actually sit right here. So you'll have the muffler right on the outlet of that control valve. And this is the same situation, right? It's just going to go through the pipe to the muffler instead of coming right out of the control valve. This might actually save you, might cost you more on tubing, might cost you less on mufflers, right? Because I need less mufflers but more tubing. So, all right. Now what this guy is going to do is we want him to operate a cylinder. So I'm going to come over here somewhere and I'm going to say, hey, I want you to operate a cylinder. So underneath my insert components, I'm going to go back into my pneumatic components. And then there's a whole cylinders submenu. Now you'll get a little bit overwhelmed with all the different types of cylinders that are in here, right? There's a double rod, which means it's dual acting. It can go this way and it can go this way. There's a cushion, both ends retracted. There's a cushion cylinder. There's all kinds of stuff. I just want a very basic cylinder, and you can show them in the retracted position or the extended position. I'm going to grab this cylinder retracted. This is the most basic one that we have in there. They also have spring-loaded. They have rodless cable cylinders, all kinds of stuff. But I just want this top right one that says cylinder retracted. And I'm going to bring him in, and I'm going to give myself a little bit of room here. I'm going to go way over here. Okay? And then he's going to get a tag number just like everything else did. We're going to call him cylinder 36. Where did that 36 number come from? It's the rung, right? The rung annotation is 36, so it's in a line with rung 36, so it's going to become 36. So now I have a cylinder, but before we plumb him up, we're going to put two more things in between. Anybody have an idea what those things are? Flow controls. That's exactly right. We need some sort of flow control in between there. So I'm going to go ahead and grab another component, and I'm going under pneumatic control. And I'll be honest with you, I don't remember where these are. Somebody can find it before me. We're looking for a flow control valve. Oh, that would make sense. Miscellaneous. And this little flow control, there it is. So there's your flow control. Now we're going to put two of those in. So I'm going to grab one. I'm going to place it kind of right in line with this port on the cylinder. And I'm going to hit OK repeat. I'm going to grab another one and put them in line with this port on the cylinder. You see how that works? I'm going to hit OK. Now again, I'm really not happy with the way those tags came in. Why am I not happy? Yeah, the tags are overlapped. So what I'm going to do is I'm going to click on this FC36A. I'm going to take that bottom left handle. I'm going to drag it underneath this flow control. Like so. And I might have to do the same thing for this one because now I'm not happy with the way they're lining up. So you can get really finicky about the details, so don't get too crazy about the details. But I have a flow control 36 and a flow control 36A. Now, can anybody explain to me how this flow control works? How?
Well, the air is allowed to flow through that check valve freely into the cylinder. But then when we reverse the cylinder, as it tries to go backward, that check valve stops it and forces it to go through that little annular, or that little orifice, or that little throttle, whatever its function is.
Yeah, so we've got a restricting, an adjustable restricting orifice is what you called it, right? But basically, this little guy here, anytime you see an arrow like that, you think of it's adjustable, right? Like a potentiometer would be, or rheostat would be, right? The only difference, though, is look what it's drawing. It's drawing kind of an hourglass shape, right? So what that's saying is it can press in and restrict flow, or it can open up more and allow flow, right? That's what that flow control does. Now, what Andrew was saying is, right now, look at the direction of the arrow. The direction of the arrow is going to come in, but none of the air is going to go through that restricting plate. Why? Because the check valve is going to allow full flow. A check valve only allows flow in one direction. So in this particular case, what's happening is air is going through here, and there's like a ball here. Imagine the air is going to push that ball off the seat, and it's going to allow flow in one direction. You guys remember diodes in electricity? A check valve is the equivalent of a diode to a pneumatic circuit. It only allows flow in one direction. So this particular flow control 36, is going to allow maximum airflow. But what's going to happen is if I plumb him up over to here, right, I got my wiring tool on now, and then I plumb this up over to here, and then I plumb this up over to here, and I can set a corner by clicking if you need to. Now what's going to happen is air is going to flow through the check valve on flow control 36. And I'm going to promise you this. Awesome quiz question next week. In the current state of that control valve, is flow control 36 flowing through the check valve or the restricting orifice? Air is flowing through the check valve for flow control 36. And then when it goes through here, it's going to press on this cylinder, right? Just like we drew earlier. And what's this cylinder going to do in the position it's in right now? It's going to extend because the air is pushing down on this cylinder, right? And it's going to extend out this way. Air then is going to return this way. As it's returning, can it go through the check valve? Why not? I'm pressing that ball into the seat, right? I'm not pushing the ball off the seat. I'm pressing it into that V. It's not allowing flow. So which way does air have to go? Through the restricting orifice and back. So no matter if I'm extending or I'm retracting, I'm still restricting airflow, aren't I? When I'm extending, I'm restricting airflow through FC36A. When I'm retracting, I'm restricting airflow through FC36. Does that make sense? We're golden on that. That one looks like $1 million, right? So now we're going to go down to the other one. And we're just going to build another one. Why? Because I put a second one in there. So we'll go into insert components. I'll go into pneumatic components, and it's good to get practice anyways. And then under pneumatic components, I'll go back into cylinders again. And I'll do another retracted, we'll do another retracted cylinder. I don't want to confuse anybody. We'll put another retracted cylinder right here. Any guess on what number this one's going to get? Well, the valve is valve 39. And if I'm in line with valve 39, it's probably going to get cylinder 39, isn't it? So I can see that that looks good. Kind of like where that's going. I do want to put those two flow controls in again. So I'm going to go back into my insert components, pneumatic components. And under miscellaneous, who found miscellaneous earlier? That was awesome. All right, somebody found it. Under miscellaneous, I'm going to grab my two flow controls. I'm going to put one up here. I'm going to maybe zoom out so I can see if it's in line with the ones above it. It is. I'll put one right here. I'll hit OK, repeat. And I'll put one down here. And I'll hit OK. And then I'll position that tag again because I don't like where that tag ended up again. I'll position this one down here. And then this one's not in a line now, so I'm going to snap him to the left so he looks like the other one. I don't know why I'm giving my flow control valves genders, but I say he. All right. So now what we're going to do is we're going to go ahead and plumb this guy up. So I'm going to go to wire. Let me zoom in a little bit. And my pressure is this line. So that'll go in there. And my exhaust, I'm going to go to the other exhaust line this time. Why? Because I have two of them. So I'm going to draw this over to the other exhaust line. Just like so. And then I'm going to go ahead and plumb this cylinder up. This one's going to go up here. And if I need to set the corner, if I want to control where that corner is going to set, just go to where you want to go and then click once, and then that'll set the corner for you. So you can determine where it makes that bend. And then I'm going to go straight across into here, straight across into here. And then I'm going to come out of here. And again, I'll have to make a little bend, I think, and go into here. What do you think? Pretty good? Looks like $1 million, doesn't it? We got our flow controls, we got our cylinders, we got our control valves. They're solenoid operated, they're spring return, they're four-way two position, that's correct. This is a single acting cylinder, it's in a retracted position. Although right now, the way I'm drawn, what position would that cylinder be in? The way it's drawn right now. It'd be extended, wouldn't it? Because the air would be coming in and it'd be pressing down on that cylinder right now, so it would be extended. You know, one thing I always like to include with any of these is I like to include a gauge. I don't know where the gauge is. Maybe it's under miscellaneous. So let's go see if we can find a gauge. Oh, it's probably under meters. Look at that. I found it right off the bat. So under meters, and then how about this pressure gauge? Pressure meter. I'm going to go to pressure meter. I'm going to place that guy right here. And he's going to get called gauge 37, GA37. And then I'm going to plumb him up by taking my wiring tool and finding out where I can plumb into him. Now, I don't want him to go to the exhaust line. Why? I'm expecting the exhaust line to be what pressure? Zero. Well, not necessarily zero. Zero with respect to atmospheric pressure. Yeah, whatever atmospheric pressure, but we're not reading atmospheric pressure. These are differential gauges, right? They read the pressure in the line and they compare it to atmospheric pressure. So it is zero with respect to atmospheric pressure. So I want to make sure that that gauge is placed on my pressure line, not on my other line. Now you can get kind of crazy with this stuff, right? Don't get rid of this right now because I kind of like what we have here. But when I say you can get kind of crazy, we could go back into insert components and we could go into insert P&ID components. And we could actually, under P&ID components, under equipment, we could grab things like compressors. So there's an air compressor, there's a rotary compressor, there's just a plain old compressor in here. There's conveyors, there's crushers, there's fans. I don't even know what else. There's probably tanks. Yeah, there's tanks. So I might have a tank. Maybe that would store energy. So I'm going to compress, and then I'm also going to have an accumulated amount of air that I'm going to store somewhere in a tank. There's heaters, all things that we can use. There's nozzles, pumps. I don't even know. Oh, these are all fittings. Is that what that says? Yep, fittings, valves. Plug valves, pressure relief valves, angle valves. Look at under check valve. Now they're showing a different symbol for check valve. So when we get into the actual P&ID drawing, in the flow control, we show the ball. And these check valves likely work off that methodology, but this is the schematic symbol for a check valve now, not a functional symbol for a check valve. What does the arrow tell me? The direction of flow. What happens if you put a check valve in the wrong direction? It's not going to work, folks. You're not going to get air through it. So you got to make sure that check valve's installed correctly. You have actuators, logic functions, instrumentation, all kinds of stuff. We're not going to use any of that for right now. We're pretty happy with our drawing over here. What we are going to do is on this same drawing, we're going to go ahead and put in what's going to control it. That's what I'm going to do. So let's do this. Let's on the right, and actually maybe we'll do this. Take that drawing, zoom out on it a little bit, left click and drag around it to select all of it, and then let's drag that guy over to the right. I'm going to put him way over here. All right? Because I want to insert something on the left, and I might even move him down a little bit, and then I could always go into my normal AutoCAD tools under Home if I wanted to. And I could grab this text tool. And maybe maybe right above this, I'm just going to pick something to do. Maybe I'll call this right here, I'll just call this service error. Now, you know what we didn't include that we could have included is we could have included a regulator. You know, we could say we have 125 PSI on this side and we have whatever the regulator, or a reducer. We also have reducing manifolds that turn things like, you know, you could have a bank with 4,500 PSI stored in it and you could reduce it down to 125 PSI. Or you could take 125 PSI and reduce it down to 20 PSI. So we could do lots of things. You know, we also have filters and separators, and what do filters and separators do?
Get rid of oil and the dust.
Yeah, so we can get rid of oil, we can get rid of water, we can get rid of dust, moisture, rust, anything. Why is it important for the air to be clean and free of all those other things?
So it doesn't come up the cylinders.
Yes, because it's just like, you know, we put in fuses to protect transformers and motors and things like that. We put in these filters and these separators. We're trying to protect the cylinders. You know, cylinders are going to be very expensive. Well, for that matter, the solenoids too, right? Those control valves and the cylinders are the expensive components here, right? A nice little filter is pretty cheap considering what you're protecting. All right, so I've got my couple of valves and I got my couple of cylinders there. Let's go ahead and put something in that maybe would control that. So what I'm going to do is on the left-hand side, I'm going to go back to my schematic tab. And this is what you guys are good at now. I'm going to go ahead and insert a PLC, parametric. So I'm going to do a parametric insertion of a PLC. And let me see. Oh, I like that one actually. Let's do that. So under your details here, apparently I've done this one before. 1769, Allen Bradley. And then under 1769, there's a discrete combination. What does discrete combination mean? Input, output, right? It's not a discrete input, it's not a discrete output, it's a discrete input and output module. So I'm going to grab that guy. You know what, though? I shouldn't do that yet, should I? Somebody tell me why I shouldn't grab him yet. There's no ladder in there. So let's go ahead and put a ladder in there first. So I'm going to escape out of that. And I'm going to go ahead and grab a ladder. Insert ladder. And this time I'm going to do single phase. I'm going to space it out 6. I don't know why I always space it out 6, folks. I'm going to hit OK. And I do want rungs. Draw rungs, yes. Hit OK. And I'm going to draw this ladder right here. And it's going to go ahead and insert it in there. And I can always move it, right? If I want to move it, I can always just highlight the whole thing. And I can move it around if I'm not happy with where it resides. Maybe I want to move it a little closer, kind of center it up with my drawing. And then you know what? well, I guess I don't know what voltage. So let's go ahead and insert the PLC now. Let's go back to insert PLC parametric. 1769, discrete combination. I'm going to hit OK. I'm going to line up that X. Now I'm not going to put it on the left, and I'm not going to put it on the right. I'm going to put it right in the middle. Why? It's got both inputs and outputs. If it was an input module, I would move it to the right. So I have room for my inputs on the left. Maybe even multiple inputs on a single screw terminal in series with each other. If it was an output module, I'd move it to the left so I could have extra room for my outputs. Because if it's a combination module, I'm going to put it right smack dab in the middle. Spacing's 0.75. I hit OK. Module, I'll call it module 1. I hit OK. I'll pick that first beginning address. What the default is, I:01/0. Now, mind you, this is, hold on a second, I want to make sure it's right. It says 6-point syncing inputs. Yes, I:01/0. I hit OK. Now it's going to say 6-point syncing inputs, relay outputs. What's it doing now here? This must be my output section, huh? We're going to find out really quick. We may be wrong on this, so I'm going to O1/0. I believe I screwed that up. How do you know?
Listed as inputs for outputs.
Yeah. So you can see my outputs right now are labeled as inputs. And it looks like my inputs are probably labeled as outputs. Looks like I did something wrong. So I'm going to hit Control Z. I'm going to get rid of that module. I'm going to try it again. I'm going to hit parametric. 1769. Okay. I'm going to place it on the rung. 0.75 is fine. Okay. Module 1 is okay. But now I know that first thing was actually an output, wasn't it? So I'm going to go under here and find O:1/0, because the first thing that it was asking for was outputs. Then it's going to do those, and then I'm going to find I:1/0 for the input addresses, and it's going to do those next. Now when I zoom in, hey, the outputs have O's and the inputs have I's. You can't hardly see them. But if I zoom in, you can see those inputs actually do have eyes on them, don't they? Okay. Now, this is the thing I love taking points away the most. What is it, guys? The extra rungs. I absolutely hate the extra rungs. So go ahead and highlight those, select them. I'm also a fan of making these rungs the right length. So another place where having that snap tool on is handy. So you stay in line. And then I also can go ahead and get rid of those extra dots, can't I? Just highlight them all. Whoa, I just messed that up bad. Well, good thing for the undo. I'll hit escape. I just want to highlight these and hit delete. Now I'm pretty happy with what I'm showing here. Feel like it's a little more representative of what I'm looking for. All right. Now it says it's VAC VDC. Why does it say VAC VDC? Remember, this is just an I/O module. This is not the power to the CPU. This is just the I/O module. Why does it say VAC VDC? What type of outputs are these? Relay outputs. So that means you can run AC or DC through them, right? So what I'm going to do though is I'm going to run DC. I guess I didn't say this out loud earlier. We didn't define it. But I'm going to assume that this control valve is a 24-volt DC coil. That's important to know, isn't it? Do they make AC coil control valves? Absolutely they do, right? Do they make different voltage control valves? Just like relays, you can get different voltages, you can get different AC or DC. So what I'm going to do is go over to here, and I'm going to make sure that my rails get reference arrows. I'm going to get reference arrows, and on this one over here, tail up, is going to be 24 VDC. And on the one on the left, what am I going to name the one on the left?
Common 0 volt.
0 volt common. I'm just going to call it 0 volt. Right here. Oh man, that's not working. There we go. And I'll call it 0 volt. That's all I'm going to call it. So now I've got my 24 volts DC. I've got my 0 volts. I feel pretty happy with those. I want, however, now to have these two drawings essentially connected. What I mean is output 0 is going to control valve 36, and maybe output 1 is going to control valve 39. So what I need to do now is under my schematic components for my electrical side, I'm going to go to the icon menu. And now I'm in my normal icon menu you guys are used to working with the PLC, right? So now I want to go find a solenoid. Good luck. I don't know where that's going to be. Somebody help? Oh, it's in the menu item called solenoids. Seems like a good place for it. So I'm going to go ahead and grab just the plain old solenoid. Now, what you're not doing this time is we're not talking about a relay with a contact. We're just talking about a solenoid. So I'm going to grab this solenoid. I'm going to place it right over here. Why am I not lining up? Did I turn off my snap?
Oh, I think it might have been off when you moved the whole thing.
Oh, no.
So if you select it all and move again.
Can I turn it on right now?
Yeah, there we go.
Snap is on. Let me see if this... I'm not confident that I'll move up a little bit. And if it doesn't work, then I'm just going to turn my snap off when I place this solenoid. So I'm going to go to solenoids. Solenoid. Oh, now I just got lucky, I think. I'm going to place that solenoid right here on output 0. Click. It's going to place it. Now this is where I'm going to be really picky about what you tag this as. Right now it's tagged as Sol 51. I'm going to hit OK, but I'm going to go over to here. I want that to align with what? With the solenoid. What did we call our solenoid?
36.
Valve 36. So I'm actually going to call this, instead of Sol 51, I'm actually going to call this guy, where it says Sol 51, I'm actually going to call it Valve 36. Why am I doing that? I want there to be a physical connection, not physical, but I want there to be a mental connection between what this guy's actually controlling, right? He's actually driving this control valve. Now, I suppose you could have called this Sol 51 or whatever, right? I would have been fine with that. But I do want it to be known that when this output turns on, then valve 36 is going to energize, and this is going to switch positions, right? It's going to go from passing straight across to the crisscross. And we're going to go from an extended cylinder to a retracted cylinder. Does that make sense? So that's valve 36. The other one's valve 39. So I'm going to place another solenoid right underneath this in that magical solenoid menu there. And I'm going to call this one valve 39. So instead of Sol 52, this is going to be valve 39. I'm pretty happy with both of those. It's not uncommon for you to see this. Let me show you a little trick here. It's not uncommon for a tag to have something like 2P behind it. Anybody know what that means? 2 position. So it's going to a valve 36, which is a 2-position valve. I'm not going to do that because it's on the same sheet. I don't need to know that. I just need to know that it's valve 36 because I can equate valve 36 to valve 36, right? Those seem pretty simple. I'm going to get rid of these other 2 outputs. I only have 2 control valves that I'm running right now. So I'm going to make sure those other 2 outputs are not wired up directly to the rail and doing nothing. And also, another little pet peeve of mine, notice the little dots. I'm going to get rid of those little dots. Why?
Unnecessary.
They're not connections anymore, are they? They're not connections. I don't want them on there. They just kind of clutter up the drawing. Now I've got a whole bunch of inputs. I'm going to get rid of input 5. And I'm going to get rid of the dot associated with input 5. But I am going to use inputs 1, 2, 3. Oh, I'm going to get rid of input 4 as well. And the dot associated with input 4. But I am going to use the first 4 inputs. Input 0, input 1, input 2, and input 3. Okay? Now when a cylinder extends out, as an example, if a cylinder is going to extend out and clamp something in. So let's say one of these robots is going to weld something, right? And one robot places a part inside of a fixture. And then the pneumatic cylinder is going to come down and clamp it into position. All right? What's really important to know before that robot starts welding?
And it's fixtured properly?
That it's fixtured, and then that cylinder's holding it in position, right? That's really important to know. Just because I turned this valve on doesn't mean that that cylinder extended. What could be wrong? Yeah, the cylinder could be bound up. It could be clogged up like we were talking about earlier. Could the air compressor be down? Have you ever walked through our machine shop down here on a day the air compressor's down? It's like Christmas down there. It's red and green lights everywhere. And it's more red than green, okay? Because every one of those CNC machines automatically goes into an alarm condition because nothing can work. Your tool changers can't work. There's everything's down. Same's going to happen here. If I lose air, if one of these flow controls is bound up, or the cylinder's bound up, or anything like that, I'm going to have trouble, right? So I want to make sure that that cylinder actually extended. So what I'm going to do is I'm going to place a limit switch. So under icon menu and under limit switches, I'm going to go ahead and grab a normally open limit switch and place that guy right here. Boom. And I'm fine with, I'm fine with calling him limit switch, whatever. No, I'm going to change the tag on that. I'm going to call it, I'm going to have to hit OK first because I don't know what I'm going to call it. I'm going to call this, we'll call it SIL36 RET. So in this tag, I'm going to change this tag to CYL36-RET. What do you suppose that means?
Return sensor.
Yeah, this is a limit switch that detects when the cylinder is retracted or returned, right? The cylinder is retracted right now. It's in its home position. That input's going to go true. Then I could do another one, right? I could go to icon menu. I could go to another limit switch. Normally open. And I'm going to call this SIL36-EXT. What's that going to stand for? Extended. So I've got cylinder 36 retracted, cylinder 36 extended, and then I'm going to do a couple more. I'm going to go ahead and grab a normally open here, and I'm going to OK repeat. You can see how quick we can go when we get good at AutoCAD, right? And I know these are SIL 39 off the top of my head, so this will be SIL 39 retracted and SIL 39 extended. So what you're starting to see now is this isn't just a control drawing. This isn't just an electrical drawing anymore. Now this drawing has both components of electric and mechanical, right? We've got a pneumatic circuit, which is part of this, and we have a control for that pneumatic circuit. And maybe this point it might make sense to kind of pull this guy up or over or something. Maybe I can line these two guys up so I can look at them a little tighter together. But now you have a really nice drawing. Now what I will tell you is this is not typical, right? Typical what you're going to see, and it's typical in the aspect of this might be the tag associated with that control valve. That's very typical. But typically what you're going to see is you're going to see pages and pages of controls. PLC module, PLC module, PLC module, PLC module, relays, contacts, motor starters, all of that electrical stuff will reside together in a set of sheets, and then the mechanical stuff will reside together in a separate set of sheets. You won't usually see both of them on the same sheet. That's pretty rare is what you won't see. What do you guys think? Feel pretty good about that? Did everybody get it done? Thumbs up? Oh, I see lots of thumbs ups. That's perfect. All right. So I'm going to go ahead and hit save because that's the one thing we didn't do is we didn't save. How often should we save?
Always.
Always. Anytime you're at the point, or you can get Mary to help you set up so it auto saves, right? So we don't have to hit save all the time. But if you ever look up there, I looked up there and I saw a little asterisk up there. What does that little asterisk mean? It means it's unsaved. So I felt a little uncomfortable, so I went ahead and hit save, right? Anytime you feel uncomfortable, you feel like you're losing you don't want to lose your work, I'm going to go ahead and hit save there and be happy with it. And then I'm going to go ahead and open up the homework and take a look at this. I'll put this in the video for the folks that aren't here tonight as well. So AENT 3120, homework 12. There we go. I hope that I didn't do exactly what you guys are going to do. It's probably pretty close. You've been given the following list of PLC I/O and pneumatic components. Use this list to develop a set of prints that communicate the correct correlation of PLC I/O to pneumatic component. So I did the same module, PLC combination I/O module. You've got outputs. You've got inputs. You'll notice I got some extra outputs now. So I've got this solenoid gripper. That's the tag it's going to get. The tag is solenoid gripper. What is this block ID that I'm looking at? Let's go look. The block ID is when you place something, it gets a block ID. I think I can go into here, I believe. Oh, do I do properties maybe?
I think it was there.
Was it there?
Oh, I saw it for a split second.
Oh, come on now.
If you double click on it,
If I double click on it,
then it's like a tag, and then just above that it has the block. HCY, is that a HCY1?
yeah, HCY. So let's go see if we can find one of these block IDs. Maybe that's a good way to do it, right? So I can see the block ID is HSV1.
Oh, there's an HCY, yeah, so it must be HCY.
So HSV1, solenoid gripper, HSV1. Oh, so HSV1, think of where this is sitting. That's not actually the cylinder, is it? The solenoid gripper is actually the solenoid gripper is the solenoid because it's attached to the PLC I/O module. So I bet you when you go back in here, right, what you're going to see is the solenoid. I bet you this guy is going to be HSV1. There it is.
There we go.
So there's your block ID. So this block ID that I included on the homework actually is going to tell you which component to pick. So the solenoids are HSV1. The air pressure alarm is HLT1R. Any guess what HLT1R might be? It's probably a lamp or light. So HLT1R is probably a red light, saying that the air pressure is in alarm state. And HLT1G is probably system ready, is a green light. And then I've got all of these limit switches here, HLS11. Those could be normally open. They could be normally closed. You'll have to look them up and see. I also have this HPS1. Any idea what an HPS1 is? Or 11?
Pressure normal?
Probably a pressure sensor, isn't it? Then I've got my four-way two-position valves. That was actually, if you went back into the drawing, I'm going to guess that we might see that might be on this guy right here, right? So there's your block ID, HVL1 four-way. And so I can see that in the homework, it is indeed HVL1 four-way, so on and so forth. Solenoid spring return, so I actually made this way too easy. The pneumatic cylinder, there's your two pneumatic cylinders, and there's your pressure gauge. Question?
So we actually, in a way, we could input all of these devices into that spreadsheet template and have it automatically generate. The only thing that would be different is that one of the ladders, it wouldn't be like a three-phase ladder, so to speak. It would be like one side.
Well, for the PLC-IO, for sure you could.
Yeah.
Right? For the PLC-IO, you for sure could. I don't know that it's worth it
This little bit.
If you remember the detail that we had to get in, typically if you're going to use the Excel spreadsheet, it would be if you are always doing things the same way, you'd have it pre-set up and you could just fill in the spreadsheets and hit boom, and it would populate your drawings, right? For this one, because it's just one, I might be apt to stay away from it. But yes, absolutely you could. Because remember, I'm going to want to kind of see the devices centered and, you know, all the other stuff. And so 2 points for each one of these items. That must mean there's 10 items here. So single sheet drawing, print it. Now here's the deal. Mary got you guys into this, so I'm going to piggyback on that. Single sheet drawing, printed on 11 by 17, properly folded, title block, scale. I'd love to see all of that stuff that you learned last week included. So Dunwoody template. It doesn't have to be my Dunwoody template. You can put it in there however you want. And I'm not even worried about the Dunwoody logo. But I do want to see the title block updated. Reference arrows used to identify the PLC ladder rails, 24 volts DC and 0 volts. Correct PLC I/O devices used. 3-line pneumatic supply and exhaust I want to see. Reference arrows must identify the pneumatic rails as PSI, exhaust A and exhaust B. Mufflers used on the exhaust lines. Flow controls properly used on each line. Pressure gauge used on the air supply. And correct pneumatic devices are used. So 10 elements there, each one worth 2 points, and you're off and running.
Okay.
Go for it.
Quick note for my homework, this was on mine last year too. When we fold 11 by 17 drawings, we want them folded so that if you would lay them one on top of each other in a 3-ring binder, you can pull them out one sheet at a time. So I still have some that were folded in half this way. If you look at the outside of it, you have no idea what the sheet number is. You don't know what's on there. And we want to make sure that it's folded in half.
Do you have a good example back there? I think you do. Somebody did a good example. Andrew's nodding his head.
Here's one. So it's folded on the bottom corner on the outside of the page. You have your sheet number right here. So when you're going through your book, it's easy to find. And it just accordions out one sheet at a time.
So nice little accordion fold on your 11 by 17, so we can actually see the sheet number from the front, and then you can just pull it out. So if it was in a 3-ring binder, you could be paging through looking for whatever sheet you need, and then yank it out and look at it, right? I love it. All right, I'm going to stop my video for those watching me online, and then